Welcome to Chem Help ASAP. Let's contrast the SNAr, or nucleophilic aromatic substitution, with the electrophilic aromatic substitution. On top we have a model nucleophilic aromatic substitution. On the bottom is an electrophilic aromatic substitution. These are reactions with full mechanisms. Both are substitution reactions on sp2 hybridized carbons. And note that both begin with an alkene addition reaction followed by an elimination, a reformation of the pi bond to restore aromaticity. These reactions definitely have similarities. They also have differences. The SNAr has an anionic intermediate, the Meisenheimer complex, and the EAS has a cationic intermediate. I don't think I've given a name for this EAS intermediate in other videos, but it does have a name. It's called the Wheland intermediate. The two reactions involve oppositely charged intermediates. The cation intermediate in the EAS explains why we often see electron donating R groups on aromatic rings. EDG R groups stabilize the positive charge and help the formation of this unstable, non-aromatic cation. It may not surprise you that the R groups we will see on rings for nucleophilic aromatic substitutions will mostly be EWGs, or electron withdrawing groups. With EWG R groups, the anionic intermediate is stabilized and more likely to form. EWG R groups help the attack of the nucleophile onto the aromatic ring. SNAr and EAS reactions are both substitutions, but the charges of the reaction intermediates are completely opposite. The sign of the charge determines the nature of the R groups that are favored for each reaction.